Today, I will introduce Sentinelle Validation System. It is a validation design tool for tabular prediction workflows. Before training a model, it helps us understand the structure of the data. For example, it checks whether the data has time, group, or panel structure. Then it recommends a safer cross-validation strategy, so our validation score is more trustworthy. The workflow has 4 steps. First, we upload a dataset. Second, Sentinelle detects the data structure. Third, we can compare different cross-validation strategies. Finally, we export the generated artifacts, including a PDF report, a JSON plan, split code, and optional comparison results. On the left side, users can upload their own CSV file. The CSV should contain feature columns, and when available, a target column. If users do not have a dataset ready, they can click Generate Sample Dataset. This creates a temporary sample dataset, so they can try the workflow immediately. For this demo, I will use the generated sample dataset. Now I click Generate Sample Dataset. The dataset preview appears on the right. This preview only shows the first few rows, just to confirm that the data has been loaded correctly. The system will analyze the full dataset in the background. Next, I select the target column. The target column is the variable we want to predict. In this sample dataset, the target column is called Target. If users upload their own CSV, they should select the correct target column from this dropdown. Structural diagnostics can still run without a target, but CV strategy comparison needs a target. I keep Compare CV Strategy selected. This means Sentinelle will run the same simple model under several validation designs. The goal is not to tune the best model. The goal is to check whether some validation strategies, such as random k-fold, may give overly optimistic scores. For the comparison model, I choose Random Forest. This model is only used for diagnostic comparison. It is not the final model. It helps us see how different validation strategies change the validation score. I set the maximum number of CV folds to 5. This means Sentinelle can use up to 5 folds. Some validation designs may use fewer folds if the data structure requires it. For example, time-based or group-based splits may have natural limitations. Now I click Analyze Dataset. Sentinelle will profile the data, detect time and group structure, check validation risks, recommend a validation design, and compare CV strategies if selected. At the top, we can see the main summary. The task type is regression because the target is numeric. The detected structure is panel because the data has repeated entities across time. The recommended primary validation design is block time split. The risk level is high, which means a simple random row split may not be reliable. Here we see a preview of the dataset. This is only a quick preview, not the full data table. It helps users confirm that the file was loaded correctly before reading the diagnostic results. The recommendation explains why panel-aware validation is needed. The data contains repeated entities across time-like periods. So a random row split may mix similar records between training and validation. That can make validation performance look better than it really is. The Avoid box lists validation designs that may be unsafe, such as shuffled random k-fold or random row split. Sentinelle also shows candidate time columns and candidate group or entity columns. In this sample dataset, month is detected as a time-like column. The state column is detected as a group or entity column. These columns are important because they influence how we should split the data for validation. The leakage risk table lists potential validation risks. For example, random k-fold may leak repeated groups. Time-like columns may introduce future information if the split is not designed carefully. Identifier columns, such as row IDs, may also create leakage if used as model features. These are not automatic errors, but they are important warnings before modeling. This section compares different CV strategies using the same simple model. Each row represents one validation design. The score shows how the model performs under that split. Here, random k-fold looks much better than the safer panel time split. Sentinelle warns that random k-fold may overestimate generalization by about 54%. This is exactly the type of risk the tool is designed to reveal. It is important to note that this is not model tuning. We are not trying to find the best predictive model here. We are checking whether the validation design itself is trustworthy. The generated report summarizes the full analysis in a readable format. It includes the detected task type, data structure, candidate time and group columns, leakage risks, and recommended validation design. This report can be saved, shared with teammates, or included in project documentation. At the end, Sentinelle provides downloadable artifacts. The PDF report is for human review. The JSON plan is a machine-readable version of the analysis. The split code provides reusable Python code for the recommended validation strategy. The benchmark CSV stores the CV strategy comparison results. Together, these artifacts make the analysis reproducible and easy to integrate into a modeling workflow. To summarize, Sentinelle helps users design safer validation strategies before model training. It does not replace modeling. Instead, it helps prevent misleading validation scores caused by time leakage, repeated groups, or panel structure. This makes the later modeling process more reliable, reproducible, and easier to explain.